Looking at 7.31, is there a certain problem in particular that y'all want to look at?
I'm currently stuck on 13.
13. Okay. I think it's one fraction.
Yep.
What's on top?
X squared plus 5x plus 36 over x squared minus.
So this is our starting problem here. Now they want us to simplify this if possible. Okay?
It's multiplying by parentheses x squared minus 11x plus 20. No, it's not correct. Oh, it's over 1.
Okay. So we have these two here. Now, as you're saying, yes, it's not divided by anything, but we can put it over 1, just so we can see it a little bit easier. And we can put the parentheses around it because that's not going to make a huge difference. Now, what we need to do is we need to factor these. We need to factor each one of these 3 sets of polynomials. Well, looking at these 3 here, well, the first one I would want to simplify or factor would be the x squared minus 49. Because since we only have 2 terms, well, x squared is a perfect square, 49 is a perfect square. So that leaves us with x minus 7 times x plus 7, because that's the difference of perfect squares. And 49 would be 7 and 7. Now we're kind of looking at the other 2. Our x squared minus 11x plus 28, and our x squared plus 5x minus 36. So we're looking at these 2 here, and at this point it really doesn't matter which one we do first. We just have to pick one. So we'll do this one here first. Now, since we look at this here, well, the 36, our third term is negative, so the signs are automatically going to be opposite. One's going to be positive and one's going to be negative. Now we're going to look at the factors of x squared. Well, that's just x and x. Now the factors of 36, I'm just going to write it right here because I don't have a lot of room. 2 times 18, 3 times 13, 4 times 9, and what is it? I feel like I'm missing some. 6 and 6, yes. Well, it's 3 and 12. 5, 6, and 6. So we have these here. And we want to see which one of these would work. Bless you. Bless you. 4 and 9. And which one would be positive and which one would be negative? 4 would be negative, the 9 would be positive, yes. Because we want that middle term to be positive, so we'd probably want the bigger number to be positive. And it does work out that this is the correct set of factors. Okay. Now we can look at the other one. X squared minus 11x plus 28. Well, since it's plus 28, we know the signs are going to be the same. And they're going to match the sign of the middle term, which is so negative and negative. Now the factors of x squared are x and x. Now the factors of 28, well, we have 1 and 28, 2 and 14, 3 doesn't go into it, but we have 4 and, well, since the signs are the same, and this is how it factors. So any questions on any of this here? Okay. Now we need to simplify what's in common on top and bottom. Well, and x minus 7. Well, they're both on top, so it doesn't simplify. Now, if it was division, then if it flipped, then it would work. But here, they're both on top, so it doesn't change it. So what we're left on top is x plus 9, x minus 4, x minus 4 over x plus 7. And I have a feeling we have one restriction.
7.
It would be 7, yes. And that's all we would need to do for this one here. Okay. Okay. Now, probably you've been noticing you've probably been noticing with most of the problems in this entire chapter is really revolving around what? Factoring, yes? And that's where I'd start. That's where I would start with any of these here is, well, except for division. Because with division, I would change it to multiplication and then factor. But most of these here, it's really revolving around this factoring. All right. What's another one we want to look at for 7.31? Any of those in particular? It's saying no? Let's see here.
Would you combine your like this?
That is going to be annoying, or semi-annoying if they do this, because what they might be saying is this here. Yep. Yes. Because what they're going to want, and again, this is, yes. I will take either one. I will take it as x plus 9 times x minus 4 times x minus 4 over x minus 7. I'm not going to require you to rewrite that as squared. But again, most of this math software, which is nice, is sometimes not nice because it wants it in a particular way. So it's wanting it with that squared. So that should give you the correct answer this time.
Could I just put in x plus 3? Or did everything cancel? Oh, wait, and x minus 2. But that all I have to put in.
Possibly. So any other ones from 7.31 that y'all want to look at, or some that y'all are stuck on? $14 or $15? This. I saw it was written like this here, yes? So what's on top? Okay. So this is the problem we have, yes? Well, I know which one I would want to factor first. Which one do y'all want to factor first? I want to factor the x squared minus 16. Because I would factor to what? Yes. Okay, so we're going to look at x squared minus x minus 12, because that looks like it'd be a little bit easier to factor. Now, because the 12 is negative, our signs are opposites. Because again, and I don't think I really explained this, why we say opposite, but if we think about negative 12, I know that we went over this one point. Because we're looking for the factors of 12, because that's why we get that last number. is the number that goes in here and here, when multiplied together, gives us the 12, yes? Well, the only way I can get a negative number when I multiply two things is, well, if one is positive and one is negative, yes? So that's kind of how we get that. Because it's negative, well, the only way two things can multiply together and be negative is if one's negative and one is positive. And that's where we get the signs. Now, the factors of x squared are going to be what? Now, the factors of 12, what do we want to use? 3 and 4. And if we check this and multiply it out, it would give us a negative x, because we have negative 4x plus 3x when we do the multiplication. And negative 4 plus 3 is negative 1. So this does work. Any questions on that there? Are you good with? Okay. Now over here we have x squared plus 2x minus 8. Well, since the 8 is negative, our signs are. X squared would give us x and. Now we can look at the factors of 8. Well, we have 1 and 8, 2 and 4. Actually, that's it. So which one do we want to use? 2 and 4. And which one would be positive and which one would be negative? Yeah, and really when we have x as 1, I think some of you might have started noticing this. If the values in front of x are both 1, we just have x and x. And the signs are opposite. Most likely the bigger number, if the middle term is positive, the bigger number should probably be positive. And that's exactly how it works out for this here. You probably also notice with a lot of factoring, it's just picking up these little tips and tricks you kind of notice as we do these. Yes? Okay. What cancels? So we have the x minus 4 and x minus 4 will cancel. X plus 4 and x plus 4 will cancel. When we do that, that leaves us with, well, x plus 3 and x minus 2 on top. Well, the only thing left on bottom is, well, 1. Because if everything simplifies out, it's just 1, so we don't have to put it over anything. But x cannot be, yes. And that there is as simplified as it gets. And on some of these, I don't think it occurs so much with the multiplication. I think it does with, actually it might. On some of them where it was asking you to simplify it, and it doesn't simplify at all, you still need to factor it. It still wants it as factors. So it's not going to accept it just as putting the polynomials back in as quadratics. It's still going in sets of factors. Is there another one we want to look at? Because if not, we can move on, or if you want, we can move on to 7.32 or a different assignment. 2x and 4x cubed would simplify. It'd be 2x squared on bottom. Because 2 over 4 would simplify to 1/2, and the x on top would simplify with one of the ones on bottom. We don't need the parentheses. And you can pull it back up and check it, because I'm guessing you ran out of checks. Okay. So it wasn't the one you were looking at? Okay. So, are there any other questions on that one, or do we want to look at the next one? You want to look at that one? Okay. Let's look at 15. Okay. X squared Okay. Well, 4x cubed isn't going to simplify at all, because that's as simplified as it gets. There's only one term. Now, the x squared minus x minus 6, that will factor. That will factor. And this one down here will factor. Now, the numerator, 2x squared plus 2x, will factor, but it's going to factor a little bit differently because we don't have 3 terms. We have 2. We can use the greatest common factor. We would need 3 terms to really do 2 sets of parentheses. Now, what's the greatest common factor between 2x squared and 2x? 2x. And if we factor this out, well, factored out 2x squared, just be x plus 1. Because we've factored out, both of those spots, the 2's factored out completely. Now, since the first term had x squared and I factored 1x out, I'm left with x. Now, the second spot, 2x, well, it factored out completely, the 2 and the x, so I'm just left with 1. And another way to think of it, it's almost like we're dividing each term by 2x, which would simplify down. Okay, now we can look at x squared minus x minus 6. Well, since the 6 is negative, our signs are opposite. Well, the factors of x squared are going to be what? X and x. Now, the factors of 6 are 1 and 6 or 2 and 3. So we want to use 1 and 6 or 2 and 3. 2 and 3. I would say the 3 is negative. Because if we look at the middle term, well, the middle term is what? Negative, yes, it's smaller. So it's a negative term. Well, most likely the negative number needs to be the bigger. Because when we have that sign change, now this really only works if we have x and x. It kind of works if we have 2x and 3x are different numbers in front of x. But we have to do the mental math to see which one's going to be bigger. So it's a little bit easier just to kind of look at it for these here and say, okay, well, negative x, okay, well, negative 3 plus 2 is negative 1. And we got it. And that really only works if the number the number in front of x is 1, because we're just multiplying by 1, so it's really those two numbers there. Now, if we look at the other one, x squared plus 5x plus 6, since 6 is positive, the signs are the same, and they match the sign of the middle term, which would be plus and factors of x squared are x and. Now, the factors of 6 are 1 and 6 or 2 and 3. So which one of those numbers add together to give me 5? 2 and 3. Now, again, that way of thinking about this only really works if the values in front of x are both 1. Because really, x times 3 is, well, 3x, yes? 2 times x is just 2x. So if there's not a number in front of x, it doesn't change what those numbers are. So we're almost combining those. But if we had a number in front of it, then it would make one bigger or smaller, and it makes things a little bit trickier. But that's also why I have y'all check, just to make sure. Because if you're not seeing it immediately, if we check, okay, I know I have the right one. Any other questions on this here? Okay, now let's cancel out what's in common. So x plus 2 and x plus 2. And right, this 2 and 4 will simplify, because 2 over 4 is the same as 1 over 2, yes? Because 2 over 4 reduces to 1/2. Now, one of these x's will cancel out with one of these here, changing it from a 3 to a 2. So let's see what we have left. So in the numerator, well, the 2 and x are gone. I just have x minus 3 and x plus 1. The 4 has been reduced to a 2. And then we have x squared times x plus 3. Yes. Any other questions on that there? Or do we want to move on to 7.32? Why don't we look some at some of the other ones and see here? Because we can look at 7.32 or 741 or 742. Because we can look at any of those there. Any one of those in particular you all find more challenging? Okay. Okay. All right, Eric, read it off. And we're dividing? Okay.
Oh, no, I did 8, my bad. I was all the way
Okay,
at 8.
that's fine. Let's do 8. Let's see number 8. That is perfectly fine. Yeah. Now, the first thing I would do with any of these divisions, I mean, I would write these out just so we can kind of keep track of it, is I would flip it. I would change it to multiplication and flip it. And the reason I do this is not because there's a written rule that states that we have to flip it first. It's just that if y'all get factoring and get going too quickly, most likely it's going to be a step that you forget, and you're going to be simplifying the wrong things or having trouble finding stuff that will simplify. So, before you factor with division, I would go on and change it from division to multiplication and flip it. Just so that you're not forgetting that step. So we look at this here. Okay, well, we just need to pick a place to start. And I'm just drawing these parentheses in because I'm just hoping that everything does factor. So if I look at the first one, well, x squared minus 3x minus 40, well, since the 40 is negative, the third term is negative, our signs are going to be opposite. Well, x at x. Now, factors of 40 would be, because we can look at those, 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, 5 and 8, and that's it. Well, if we look at these here, which two do we think would work? 5 and 8, yes. And which one would be positive? Which one would be negative? Yep. Because 5 minus 8 is negative 3. And that, again, it works because we have 1 in front of x. And those are the factors. I can just drop straight down. Well, since the 20 is negative, we have opposite signs. And well, the factors of x squared are just x and x. So since there's only one set of factors and we know the signs are opposite, might as well just throw it in. So now we're looking at the factors of 20. Well, 20 is 1 and 20, 2 and 10, 4 and 5. And we're wanting the middle term to be what? 8. 2 and 10, because again, since the signs are opposite, we're going to be subtracting numbers. Well, 2 and 10, and 10 would be positive since x is just x and x. 10 minus 2 is positive 8. All right, we look at the next one. Well, 20 is positive, so we have the same signs. X squared would be x and x. This time we want to get 12, yes? Well, so they're going to be combining. Factors are, 2 and 10, yes, they work again. Which one need to go first? I mean, they're both positive, it doesn't matter. Okay. Well, that brings us to the last one, yes? 40 is positive, so the signs are the same, and they're both going to be positive. X and x. So factors of 40, they give us 13. 4 and 10 would give us 14. They're going to be, works out 5 and 8. I think they're trying to be funny with us here. But essentially, we got the same, except for some sign changes, they pretty much look the exact same. Now we just need to so x minus 2 and x plus 2 look like they would, but because the sign's different, they wouldn't cancel. X plus 10 and x plus 10, and the x plus 5 and x plus 5 would. And I mean, if the signs for these here, the x minus 8 on top was the same, if the ones over here had both been positive, then everything would have canceled, and it would have given us 1. And it is possible for that to happen. But here we're left with x minus 8 times x plus 2 over x minus 2 times x plus 8. And here x cannot be. One more spot? Ah, yes. Negative 5, negative 10. Because, like we've said, if I get a highlighter out, that's not a highlighter. We can't have the denominators being 0, yes? But because, again, we're dividing, neither part of this second one can be 0, because since we're dividing these two together, when we look back at the top, if the second rational expression becomes 0 at all, then we're dividing by 0. And that's where that's coming in. So, really, when we look at the restrictions for division, anything that is, because when I looked over here, well, x plus 8 was in the denominator, it's still in the denominator, yes? So that's kind of a restriction, it's still listed. X plus 5 is gone, we have it. X plus 10 is gone, but we have it, yes? So the only thing we're missing over here is the x plus 2. So the one that we're dividing by that we flipped when we changed it to multiplication, anything in that would make it 0 that's still listed needs to be counted as a restriction. and anything that canceled out of the other denominator. All right. Let's look at another one. Number 11?
No, 1.
Number 1, 2xyz over Okay. So when we look at this here, again, before I start going and canceling anything out, I think what would be the best option is, well, change it from division to multiplication. And flip it. Now at this point here, we went over two completely different ways to look at this here, because one way we did is we actually multiplied everything together. So we multiplied all the terms together and then reduced. And then the other way is, well, we looked at the terms and see what canceled out individually. Now there's a third way we can do it, which is a combination of both. And what I mean by that is if I look at this here and I see anything that would simplify easily, so if I have an x term by itself on top and an x term by itself on bottom, get rid of them. If I had, so here I have an x cubed on bottom, well, hey, if I saw an x cubed term on top, get rid of them. If there's anything that we can see matches up nicely on top and bottom, we can get rid of them. If not, well, here I have x cubed on bottom, but I have an x and x squared on top. So it's a little bit hard to see that. That's fine. But, well, hey, 2 over 6. Did that reduce?
Yeah.
1 over 3. And that's the only one that really looks like we can reduce it pretty easily. We can just see it. So let's multiply the rest together. So if I do that, let's see what happens on top. Well, I still have 1, 2 left over on top. X times x squared, that would be x to the third. I have 3 of them, yes? Y, okay, y is by itself. Z times z squared would be z to the third, because I have 3 of them. On bottom, I have a 3. Well, we have x cubed, y to the 4th, z to the 3rd. Because there's only one set of each term on bottom, so there's not really anything being changed. Oh, wait a minute. I have x to the 3rd over x to the 3rd, yes? They're gone. Well, z to the 3rd over z to the 3rd. They're completely gone, yes? I have 1 y on top, I've got 4 on bottom. What can we do? Mm-hmm. 4 minus 1 is 3. Is it bigger on top or on bottom? Bottom, it stays on bottom. So what we're left with is 2 over 3y cubed. And it has x cannot equal and z cannot equal, correct? Was there any addition or subtraction in any of this?
0.
So they both have to be 0. Okay. Are y'all good if I move on to number 2? Okay, let's look at number 2. Eric, you want to read it off?
32x cubed y over y8, and then divided by y7 over 8x.
Like this here? Okay, well, again, the first thing I would say before we do anything is I just change it to multiplication. Is going to be the easiest thing to do first. So change it from division to multiplication. Okay. Now when I look at this here, well, wait a minute. What is the only thing that's similar on top and bottom? We have y, yes. Y is on top and bottom. That's the only term on top and bottom. So it doesn't matter which one I do this with. I'll do it with this one here. This y, and this one will simplify it down one. It'll turn y to the 8 to y to the 7. So are we good with that step there? Well, that's it, isn't it? That's the only thing in common on top and bottom for any of this here. So let's multiply it and be done. Y to the 7th times y to the 7th, that'd be y to the 14th. We add those exponents. X to the 3rd times x to the 4th would be x to the 7th, yes? 8 times 32. 8 times 2 would be 6. Carry the 1. 8 times 3 is 24, plus 1 is 256. And anything fully, well, and then it has x cannot equal, yes? 0. And the reason they include that here is because, well, when we started out, x was in the denominator as part of the division, so it doesn't work. All right, guys.